Good afternoon, students. I am Pankaj Kumar Gupta from ABS Engineering College. Today I will discuss about electrical installations. Now, this is a part of the syllabus in AK2 of first year, that is under basic electrical engineering. Here, this is being covered under unit number 5. But why do we require electrical installations? This is important. That we have to see. Now, first, it's important that what will be covered under this unit. What are the switch gears? What are the protection schemes? What will be? Here I've got switch gears which are 5 of types. This is part of the syllabus. SFU, that is a switch fuse unit, miniature circuit breaker, molded case circuit breaker, that is MCCB, earth leakage circuit breaker, and air blast circuit breaker. Also, we will covering up earthing, cable and wires, batteries, bus bar arrangement, and lightning protection. Now, this is important because this is part of the syllabus. Now, in switch gears, if you see that they are breakers. What is the role of a switch gear? Why do you require switch gear? This is very important. This is very, very important. Now, for this, let's discuss the necessity of switch gear. Now, it is used, it is widely, why is it used? To control, protect, and isolate the electrical equipment from any electrical. Faults can be of many types: overcurrent, earth fault, short circuit. So, it can be anyway. We have got three-phase system. It can be between any two phases. It can be between one phase and the earth. So there are many types of electrical faults. But in each case, to safeguard the machines, anybody, a person also is working, he requires switch. It also provides safety, reliability, efficiency, and cost effectiveness to the machine. Now, in electrical power system, that is being divided into three parts. That is generation, transmission, and distribution. Generation is always done at high voltage. There are certain advantages that we will not go into that, but there are advantages with regard to high voltage. You don't generate electricity at low voltage. You see any power plant anywhere, they are all generating above 11,000 volts. That output voltage, generated voltage is above 11,000. Now, accordingly, the transformers which are installed near the generator, they are within that power system, the power station, generating power station. They are also of high. The ratings of those transformers also are very high. Because as far as transmission is concerned, the power is transmitted at a much higher voltage than the generated voltage. Then we require a step-up transformer. So that step-up transformer is very, very large. And the rating of such transformers is very, very large. It's an MVA, that is megawatt, megavolt amperes. Similarly, the generator generating electricity or power is also in terms of megawatt. So and the cost of these electrical machines is just two basic machines which I'm telling you. There are many things also involved in them. Protect them under all electrical fault conditions, we require switching. Because if the fault damages the machines, then we have got no other alternative than to replace them. And replacing an electrical machines is very costly affair in all respects. First, loss of generation, and the economical cost is very, very large. So to avoid all these disadvantages, we require switchgear. The switchgear is very, very important. Normally, it breaks the circuit instantly. Then, so in my slide in this lecture, let's discuss the first type of switchgear. That is the switch fuse unit. A switch fuse unit consists of a fuse and a switch. That is a manual switch, which we'll see later on. It protects the electrical circuit from overcurrent. It's widely used for low and medium voltage. Now let me briefly just go through this low and medium. Now, in a power system, that is electrical power system, we have three types of voltage. This is low voltages, medium voltages, and high voltages. High we consider above 11,000 volts. Medium may be between 440 and 11,000. And low is always between 0 say. That means minimum we are using at 110 volts. In India, we don't use 110 volts. It's another issue. In India, we are using minimum 230 volts for domestic. For controlling equipments of small rating that we are using, that step up low voltages. But any low voltages below 440 is low. So this is used only for low and medium voltages. Now the current rating of the SFUs are 30 amperes, 63 amperes, 100 amperes, 200 amperes, and 400 amperes. That is, this type of switch gears, this type of fuse unit, they are used in very small ratings because they are basically used in which part of the system? The lower voltage. Also, we know that the power system is divided into three parts broadly. That is generation, transmission, and distribution. Now, these SFUs are widely used in distribution system to make and break the circuit at any instant. Even if you have to give supply to any motor or small rating, there also we require SFU. The help of a starter. But the SFU is required to give the supply to the machine. To run any mechanical machine, we require always a motor. To give supply to the motor, we always use SFUs. Now, SFUs are also of two types, single phase and three phase. In single phase, you've only got two fuses. In three phase, you've got three fuses. This is a manually operated fuse unit, always. But that we require to make and break the. It protects the electrical circuit from current. Maybe also from short circuit, because under short circuit, it will use a large amount of current to flow into the circuit. Due to which, again, the system will act over as over circuit. The fuse will get fused. It is widely used for low and medium voltages, and the current ratings are very small. It can be used for single phase as well as three phase. Now, this is a schematic diagram of a switch fuse. Here, if you see, it is a three phase switch fuse unit. Here we have got three phases, 1, 2, and 3. This is your KitKat fuses. And this is made from a porcelain. Here there's a fuse wire, which is normally of silver metal. And down the fuse, we have seen 6 terminals. They are being used for, this is outgoing terminals. In the top, there are 3 incoming terminals. The cable will come from the top of the SFU, and the outgoing will be from the distribution from this outgoing. Here also, you have to keep in mind that there is a switch. This is a manual. Whenever you have to give supply, we turn the switch, the handle onto the upward direction. So the contacts come into contact, and then incoming and outgoing, they have a common. In case of any fault in any one of the fuses, the fuse is replaced here. So this is a time consuming as far as replacement of fuse is concerned. Normally, what happens is that we don't get the wire, the size of the wire, current rating of the wire, which is being used. So under this condition, what happens is that we sometimes either we replace it with an oversized wire, or undersized wire. Due to which, again, the system will become faulty because under overload condition, again the fuse will get fused. Normally, we should have the same rating of the wire with the same gauge wire size, which is being used in the original manufacturing. There are many types of SFU units, and we should remember one thing: this is just one of the basic switch gear of the system. Very, very basic. Just to make and break the circuit manually. It is manually. It is not automatically. It is just a manually operated. Now, these are the references which I have been using, which I have used for these particular lecture. The diagram of SFU has been taken from the second part. The third and fourth are the course lines which are used. This is being used only for teaching and education. Thank you, everybody. Thank you, students.